Okay, so please join me. 2.4 algebraic expressions on page 145 of your textbook. Start by looking at page 147. Briefly skim page 147. You'll find the key idea. We're going to talk about those 6 properties in just a moment. Now, join me in your reflective journal as we take notes. The first thing that I'm going to review is perpendicular. So looking at the chapter 2 vocab, we see the concept of line perpendicular to a plane. Again, line perpendicular to a plane. This is review. We see that chapter 2 vocab, and we also see the chapter 2 vocab of perpendicular lines. Perpendicular is the phenomenon in mathematics of something intersecting at a 90-degree angle. So when a line is perpendicular to a plane, that means that we have a plane, such as plane P, in which a line comes in and cuts through the plane at a perfect 90-degree angle, so that the line pokes in, creates a hole, and then comes out the backside, and there is a 90-degree angle here. Okay? Now, line perpendicular to a plane, you can think of this as a floor, and they're going to put in like a cement rod or a steel rod to build a tower, right? There's a lot of perpendicular phenomena happening in construction. As you can see, the board is perpendicular to itself, all of that jazz. This is labeled as line L. So line L here is perpendicular to plane P, okay? Now let's talk about perpendicular lines. So we're going to talk about what perpendicular lines look like. 2 lines are perpendicular when they intersect and form a perfect 90-degree angle. So here, line L is perpendicular to line M. This is one way that they might let you know that 2 lines are perpendicular, by putting a 90-degree angle. There's another way that they can let you know that they're perpendicular, and what would that be? The box, yes. When we see the box, or as I like to call it, the perpendicular marker, it's telling you that line L is perpendicular to line M, and that this also forms a 90-degree angle. Again, that perpendicular marker denotes a 90-degree angle. Let's go ahead and talk about another way that they might let you know that line L is perpendicular. In the directions, they might have line L and line M with an upside down T. Whenever we see an upside down T like that, it is telling you that line L is perpendicular to line M. Okay? It's saying L is perpendicular to N, which is this. So, to review, there are 3 ways they might tell you 2 lines are perpendicular. The first is by annotating it as 90 degrees. This isn't as common. The second is to give you a perpendicular marker. That is the most common. And the next one is to do line L is upside down T to N, which they'll do this when they're trying to trick you because they think you're silly, but you're not. Line L is perpendicular to line M. That's the 3rd way that they'll let you know. And they will use this, I guarantee you. Capiche?
Comprehended.
Now let's go ahead and review one more concept. Here we see that because we know that this angle was 90 degrees, we know that this angle was 90 degrees and this angle was 90 degrees. One of these is a linear pair, the other one is a vertical angle. Who can tell me which one of these is the linear pair? Sierra?
No on the right?
Mm-mm.
No?
Mm-mm.
No.
So that, yes. So this is a linear pair. Write this down. A linear pair, the best way to remember it, is 2 pairs, again, a linear pair two pairs on the same side of a line. So do you see how this angle and this angle are both on the same side of the line? So that's a linear pair. Linear pairs always add up to 180 degrees because one side of the line is always 180 degrees. And that means that linear pairs are supplementary. Linear pairs, again, are always supplementary because one side of a line is always equal to 180. And supplementary are two angles that equal 180 degrees. We're taking notes in your reflective journal and we're on page 147. These two are vertical or opposite from each other. So that means that they're vertical pairs, vertical angles. And vertical angles mean that they are automatically congruent or identical. So go ahead and have this written down in your vertical angles are opposite from each other. They're vertical and they are congruent. Linear pairs are on the same side of a line, and because they're on the same side of a line, one side is 180 degrees, and a linear pair then is always supplementary. Excellent notes. Okay, great. Now, just so we know, this was 1.6. We're reviewing it, linear pairs and vertical angles. When you have understanding of a linear pair and a vertical angle, you can find the angle measures of every single angle in intersection. So what that means is linear pairs and vertical angles are the foundations of all angle relationships, and you will be talking about this frequently whenever we talk about angles, okay? So we already took notes on this, we're taking notes on it again today, and we'll do it again in the future, because these two concepts are the building blocks for all other angle pair relationships. With that, we're ready to move on to page 147. Page 147. Now we're taking notes on algebraic expressions. So, 2.4, algebraic expressions. Algebraic expressions. Class, what is x equal to?
4.
X is equal to 4. Is that obvious?
Yes.
We like it when we see x equals a number. This is the format that we like, isn't it?
Yes.
What about now? Tell me what x is equal to.
You don't know.
You do know. You have to solve, don't you? So is this as easy to tell what x is equal to? For some of us, but for others, and really it can get even more and more complicated. The distinction here is when we have x equals a number, we like that. But when we have a number times x plus a number equals a number, it's more difficult to find out what x equals, so we have to solve, okay? The point of section 2.4 is not only to solve basic algebraic expressions, but also to describe it. So as you look at this, I'm going to journey off into the realm of a story. Are you guys ready for a quick story?
Yes.
Let's say an alien crashes in your backyard and knocks on your door. And the alien has gold, it has diamonds, and all it wants is a friend. Are you guys going to be best friends with the alien?
No.
Yes.
Maybe.
Yes, you're going to be like, hi, welcome to planet Earth, how can I help you?
Once I jump in reality that they real.
Yeah. But the alien, as it's talking to you, has horrible stink breath.
Oh.
So you can either say, I'm sorry, alien, I don't want to be your friend, and turn away the riches, turn away the diamonds, turn away getting to ride in a cool spaceship, or you can teach the alien to brush its teeth. What are you going to do? Teach the alien to brush its teeth. Now, you brush your teeth every day, but you don't necessarily explain brushing your teeth, do you? So it would have to be step 1, grab toothbrush. Step 2, grab toothpaste. Step 3, put toothpaste on toothbrush. Step 4, wet toothbrush. Step 5, Put toothbrush to teeth. Step 6, side to side motion. And you would go on and on, right? Have you guys ever done that? No. In here, not only are we brushing our teeth, but we have to explain each and every step. Okay? So just know, you're solving and you're explaining. Now, would it be complicated to explain a step-by-step 20-point skincare routine to an alien?
Yeah.
Would that be kind of out of your league?
Yeah.
Yeah. So the point is, they're not going to give you a 20-step algebraic expression. They're going to give you a small, simple algebraic expression, which means if you don't like algebra, with a very basic understanding of how to solve, if you take the time to learn the very basics of algebra, you won't need anything else. Capiche? So if you don't like algebra, this can be an opportunity for you to learn what it takes to have the foundation ready so that when you're in Algebra 2, you're not so lost. I'm going to try my best to start from the foundation, so even if you hate algebra, this becomes a little bit more clear. Now, we are looking for our beautiful x equals, aren't we? We like the x equals. In order to do that, we have to do something called isolate the variable, which is making the variable all by itself. We want x to be on this side of the equation, the equal sign, all by itself. In order to do that, we have to make this go away and this go away. Which one is farther, the 5x or the plus 5? Which 5 is farther? The plus 5. So you're going to start farther away and you're going to go into the x. Let's start over here. What's the opposite of adding 5?
-5.
Negative 5 or subtracting 5. Are you going to do that to one side or both?
Both.
Both. That is known as the subtraction property of equality. And after you use the subtraction property of equality, you have 5x plus 5 minus 5 equals 30 minus 5. So in order to move forward, you have to simplify. After you use a property of equality, you'll always simplify. So, what's 5 minus 5?
5. I mean 0.
0. Do we have to write that or can we ignore it? We can ignore it. What's 30 minus 5? 25. And then we bring this down, okay? We bring it down and we have 5x is equal to 25. Now, 5x is a fancy way of saying 5 times x, isn't it? 5x is a fancy way of saying 5 multiplied by x. So what's the opposite of multiplying x by 5? Division of 5. So we can divide by 5. Are we going to do that to one side or both? Both. So we have 25 divided by 5. That is the division property of equality. The division property of equality. Now we're going to simplify. What is 25 divided by 5? 5. We have the equal sign. What is 5 divided by 5? 1. And then, so we have 1x. Do we need to write the 1x or can we write it like this? Yes, that is 1x is equal to 5. And that is our answer. Do we see how we use the properties of equality and simplification to solve?
Yes.
Did this help with a little bit of solving algebraic expressions?
Of course.
You want to start with locating the variable and then isolating it by taking the numbers away by doing its opposite, starting with the farthest number. You wouldn't start with dividing 5 first because it'll complicate everything. Okay? You want to start with the addition or subtraction and then eventually get closer and closer to the x until it's all by itself. Go ahead and turn now to page 149. Again, on page 149, independently, you'll want to do problem number 1, number 3, and number 5 in your no longer needing to take notes in your reflective journal. You can go ahead and start, actually wait, I do apologize. We're actually gonna start at the very front, oopsie daisies. 145, start solving section A. So join me on page 135.
145?
Yes, 145. Now on page 145, they give you an algebraic expression and then they give you the justification. I'm going to focus only on the justification because I don't want to copy the whole thing, okay? The first thing underneath the justification, now this is how obvious and this is how much explaining we have to do, that they literally explained the fact that they wrote the given expression. Can you believe that? They literally said, please start solving by writing the expression down. Can you believe?
Yes.
Write the given expression. Now, the given expression is 5 divided by 2, parentheses, x plus 4, close parentheses, minus 6 equals 5x plus 9. Again, that's 45 part A. Underneath that, we see that the parentheses disappeared and 5 over 2 was multiplied to the x and multiplied to the 4. How did they do that? What property did they use? They used the distributive property. So the first property they used was the distributive property. And you know that because they distributed or they multiplied 5 over 2 to x and 5 over 2 times 4. That's why the parentheses went away, because they distributed it. After you use a property, the next step is always to simplify. So whenever you use a property, just know underneath it you'll write simplify. Now, after we simplify, they combined 10 minus 6. Do you see how 10 minus 6 turned into plus 4?
Yes.
They simplified that. Now, underneath that one, we see 5 over 2x minus 5 over 2x plus 4 equals 5x minus 5 over 2x plus 9. What two terms are in this new expression that weren't there before?
So negative 5.
Negative 5 over 2x. Is that, so what are they doing to both sides? Subtracting. So they are subtracting 5 over 2x to both sides, which means they are using the subtraction property of equality. So go ahead and write that down in the line. After you use the subtraction property of equality, you're going to what? Simplify. You're going to simplify. Okay. Now we simplified by doing 5 over 2x minus 5 over 2x, which is nothing, and 5x minus 5 over 2x, which is 5 over 2x. So now we have 4 equals 5 over 2x plus 9. After that, we see 5 minus 9 equals 5 over 2x plus 9 minus 9. What two terms did they add in that weren't there before? They subtracted 9 from both sides, didn't they? Which means they used what property of equality? The subtraction property of equality. And after you use the subtraction property of equality, you're going to simplify. Great. Now we have simplified negative 5 is equal to 5 over 2x. The next step, we see 2 over 5 times negative 5 is equal to 2 over 5 times 5 over 2x. What did they add in that wasn't there before? Multiplication, which means they used what property of equality? The multiplication property of equality. And after you use that property, you're going to simplify, and you have your simplified answer, which is x is equal to negative 2. So again, not only are we solving, we are explaining the justification using the properties of equality, including the distributive property. Let's go ahead and now turn to page 149. You'll want to solve number 1, number 3, and number 5. For the rest of this video, I will also be solving number 1, 3, and 5. If you have enough understanding, you can go on to the homework. If not, tune in as we solve 1, 3, and 5 together. But for now, try to solve it on your own. Page 149, number 1, 3, and 5.